All right. Hello again. Welcome, everyone. Thanks for joining us. This is our last and 31st live stream of the year. So we're super excited. We did not miss a week this entire year once we got going in the spring. And we're really excited to have this final one because today we not only have one guest, Ritesh, who you've seen before, but we also have Chai with us. Chai, welcome.
Hello. It's nice to meet you.
Yeah, absolutely. And Ritesh, welcome again.
Hi, it's nice to be back again.
Absolutely. It is. It's great to see both of you because today we're going to not show a feature or a part of our platform. We're actually going to talk about an important conference that happened earlier this month, which is NeurIPS 2025, which the two of you had the good fortune to attend. And we'll get all the way into that. And I know, Chai, you actually were involved with a few nonprofits that put together some really important events around data sets and curation and so on. So we'll get into that as well. To begin with, Chai, you said no crazy claims were going to be made today. Is that still true, or how do you hold to that?
Well, I mean, I think no crazy claims are going to be made by us today.
Okay. But we will discuss crazy claims. Okay.
Oh, we'll absolutely discuss the craziest claims we heard.
Okay, fantastic. So let's get straight into it. I mean, I know most people that join, obviously, part of it is about meeting people and learning and taking notes, but you also attend keynotes, obviously. So we'll start with that. Ritesh, like, what are some of the best keynotes that you attended? And maybe we can get into those, and Chai will ask you as well.
Yeah, sure. So there were really good keynotes. The keynotes that stuck in my head are Art of Artificial Reasoning. This is by Professor Yejin Choi. So essentially in her talk, she talks about reasoning, evolution of reasoning, and how small models are also getting better at reasoning. To paraphrase one of our quotes, the age of brute force in AI is over. Essentially, by that she means RL is scaling, and with RL you are becoming more and more sample efficient. She also talks about synthetic data and how RL is mitigating the problem of lack of data.
Awesome.
Next,
okay. So that was one of your favorite ones. Chai, what about yourself?
Actually, that was my favorite one.
Okay.
Yeah, I was actually really impressed by what she said. And it was also really interesting because I think a lot of people don't realize that what we're calling AI and ML right now is a lot of brute force. Because a lot of this technology has been around since the 80s. Like the math was figured out. It's just that we didn't have enough compute. And now that we have compute, we're kind of like saying, oh, look, it's magic, because it's fast enough now where it looks like it's responding on the at the speed of what a human or a biological organism would. And so people are like, oh, look. And it's like, well, the compute just got faster.
Yeah, the compute indeed did get better. But, I think, understanding how to, define and formalize attention heads and just the optimizations of creating sort of the new attentional network and everything that goes with it. That's all innovation, though. I mean, that did not exist in the 80s, right?
Well, actually, people really tried to sell a lot of this, and this is why there was a whole time of AI darkness where you couldn't get funding and you couldn't get a company off the ground by saying, yes, I'm doing AI. I mean, AI was a really dirty word until about 6 years ago, because people were just like, oh, no, we can't do it. Everybody called it machine learning because it didn't have that kind of like, taint to it, because it really got oversold back in the 70s and 80s. And that was kind of like, the dark ages, so to speak, where you just couldn't talk about it and actually get taken seriously. So there's that. But then there's also, I want to say, a lot of what we're calling AI and ML sometimes is, the magical claims. It is just arbitrage, right? Like people are just like, yep, we're just gonna outsource that to a cheaper country and someone's going to take over the machine and it will look like magic. So, there's a certain amount of that claim that's out there. And I think a lot of the thinking is, well, we'll just do that for a while until it gets good enough, until the machines get good enough and the people train it fast enough, and then it will be magic and it'll be machines. So it's a very typical hype cycle in a lot of ways.
Yeah, I mean, we saw this even, maybe 10, 12 years ago when maps were getting really good. And, people said, well, gosh, like, I wonder what's happening every time I say that route was not correct. And what you realized was there was somebody behind the scenes who was actually checking to see if that was really a stop sign or if it was a four-way crossing or not. And I think we've seen this in industries. When you start to productize things, you do need to fake it till you make it in some ways. But I mean, going back to the NeurIPS subject, I know when we were talking earlier, you talked about how you knew about this conference back when it wasn't even NeurIPS, it was NIPS. So tell me, how has it changed in your mind? I mean, I know, Ritesh, I'll come back to you as well, because you haven't attended before, but like, how do you think it's changed? And if you've been to other conferences, AI conferences of late, what do you think is different now versus what you remember a few years ago?
Well, so I have not attended NeurIPS before, and I definitely did not attend NIPS, but I knew a lot of people who did go, and I would talk to them about it. And so it was very much academic, and it was very small. So it started in 1987, and there were basically like just a few hundred people who would go, and it would be, like, I think it became like maybe just, not that many thousands. But for it to kind of balloon in a very short amount of time, like I think in the last 5 or 6 years, really wasn't when it really took off. I think the amount of money thrown at the conference has really changed. And, you still have to be impressed by the fact that this is still a volunteer-run conference.
Yeah.
At, I think I've seen different claims of how many people were there, up to 29,000. So it's like, it's a lot for academics and, researchers at companies to kind of go, okay, I'm doing this part-time, when I'm not working on AI research.
No, for sure. I mean, I remember, I haven't necessarily gone to an academic conference in a few years now, but I remember when, distributed systems, were a big thing, and containerization started to get really interesting. And I'm talking about sort of like the maybe a decade ago. People were this was a breeding ground to meet people that you wanted to work with or you wanted to learn from, or people whose papers you had read. And I always kind of made it a point to reach out to them before I went and said, hey, let's meet for coffee, or when are you going to get there? And maybe we can meet here. I'll send you my phone number. And, it was almost like a mini, like sort of dating site to kind of find people who you were looking up to, or, whose work you had read about, or maybe they were just commentary, providing really high quality commentary on LinkedIn. So Ritesh, did you have that moment? Did you reach out to people, or just maybe serendipitously meet people that you had maybe reached out about, or maybe tracked online?
Yeah, definitely. I mean, there were a few speakers like Nathan Lambert and others who I've been following beforehand. Nathan Lambert has an blog and so on. So I met with them in conference and workshops. And also, surprisingly, I met a lot of people from my undergrad there. And it definitely wasn't planned. I was just walking around and I saw some of my friends who were doing PhDs or who finished their PhDs and are working at some of these research labs.
What is it? I mean, perhaps you hadn't necessarily talked to them about AI before this meetup. What is it about their perception of how it's going to help change what they're doing, or change technology, or change the quality of the products that we use every day? How is their perception the same as yours, or maybe different? Like, how would you, when you talk to somebody after a while, you sort of hear out what they see and what they're looking forward to and what they're excited about and what they think is within the walls of reasonable expectations in the next 2-3 years. How does their perception differ from yours, and how is it the same, perhaps?
Yeah. So talking about similar, it's more in the sense of what everyone in my circle was researching on or using a lot. That's obviously transformer and LLM models. I think it's because of the group or interest group. I got to meet with a lot of people there, and actually we, in terms of differing opinions, we had different opinions on how would the model interpretability field pan out how will it pan out over the next couple of years.
Yep.
So you were thinking, it's possible to entirely explain or build inherently interpretable models, which basically say that model, whenever it generates, should be able to explain why the generation is. And some of us are of the opinion that's not so easily possible. So that's one of the differing opinion, or one of the debates I had with my bunch.
Yeah, and I know I've talked to some people who feel like either way, it doesn't really matter in terms of the actual, forecasted use cases and so on. So fascinating topic. I know there was actually a tutorial on interpretability. I don't know if you attended that one, the one by Shichang Zhang and Julius Adebayo.
Yeah, it's one of my favorite tutorials.
Okay.
So yeah, it provided an entire overview or Hawkeye view into interpretability for someone who isn't so deep into interpretability. I just had read bunch of new papers, but this tutorial was really gave me a kickstart into interpretability and also made me more interested. And the second half of this is where Julius Adebayo actually talks about building inherently interpretable models, and then how does scaling look like for those models.
Mm-hmm. And what's his background? Like what institute or company is he associated with?
Yeah, I think he's from MIT.
Okay.
PhD from MIT, and he's now has his own startup called Guide Labs.
Got it. Chai, did you spend any time looking into the mech interp or interpretability topics over at NeurIPS, or not your thing?
I actually spend a lot more time on the data sets and data governance side, because that's kind of where I'm kind of living more right now.
Got it. And so tell me about that, because I know you had an event where several nonprofits actually were involved, ML Commons and others. Maybe you can take a moment to just kind of share what you guys were able to accomplish and what kind of event it was.
Yeah, we actually had an official social at NeurIPS. So it was 3 different nonprofits, and we were all talking about data sets. And so I've been working with Wikimedia for the last 4 years on product research. And it was basically Wikipedia. So Wikimedia is the foundation.
Yeah.
That brings you the biggest project that people know is Wikipedia. And we've been doing a lot of research into how reusers have been basically using the data so that we can kind of give them a nice carrot to come to our APIs instead of going to scrape the site. Because there's a 25-year sort of like, we just go and scrape your site. And it's like, well, you're actually really hurting the movement in a lot of ways, because you're keeping people from being able to reach the site. Because when Carter died, for example, the bots were crawling that page so heavily that people could no longer reach the page. So we're really trying to get people to understand how to work with Wikipedia data sustainably. And then AI Alliance has an open and trusted data initiative that we are also a part of. And so they're really trying to put out like, here's where you can get clearly licensed data, data sets that, have some form of trustworthy and verifiability on that when you take it in and train models on it, that there's some kind of standard that it's being held to. And also ML Commons is working on Croissant, which is a data set, I guess like organizational standard, if you will, so that it's you can say, okay, we all agree that this is what metadata should look like for this type of data set. And so it's
you guys are focusing on like formats that are suitable for pre-training or post-training, or what do you have in mind?
I think that I should let the ML Commons people talk about that directly. Got it. They're definitely focused on, just how do we structure data sets so that it's interoperable more or less. And we actually had some really spicy takes on data sets. Like Steve Pausty from AI Alliance, he's actually from Red Hat, and he said, can we truly have an open source model if the data is not open source. If you don't tell me how you got the data and what it is, you gave me the weights, great, but I can't remake your model.
Sure.
And so he's like, is that really open source? Is that what the word means now?
Yeah. Well, which is why people don't, have been so restrained in using the word open source model, right? People will often say it's an open weights model or something like that. So I agree with you. I got a quick question though, because a lot of us, I've been amazed at like sort of my own patterns of behavior where I'm now using, the typical, frontier models and their products to ask questions that I would have maybe used keyword search for, a year ago. And how do you see that affecting, product sites like Wikipedia? Because think about it. If I have a question about, something, there's a theory in my head about, something that happened in, I don't know, some prehistoric era or some kind of event of, the last century. I would have typically gone down the rabbit hole of Wikipedia. Like going down the rabbit hole of Wikipedia for me, some years back, pre-GPT, was a very enjoyable evening after dinner, right? And if you think about it, I'm kind of going down the rabbit hole on GPT now. So is it taking eyeballs away from what would have been a highly productive or unproductive sort of night on Wikipedia? How do you guys think about that? How do you sort of coexist with this?
I mean, it's something that we're really thinking very hard about. How do we work with, the model makers and how do we have some kind of attribution? I mean, attribution is a really big deal for a lot of different people. So this is something that we are definitely concerned about, which is why Wikimedia Enterprise exists in a lot of ways, because we're like, oh, we're going to get disintermediated away from the eyeballs or the people who are, so yeah, it's a thing we don't have answers for it right now. Cause I mean, we wish, but everything's just changing so quickly that it's like, well, we're going to try to build the plane as we're flying it.
For sure. Ritesh, coming back to you, like just reinforcement learning. I mean, it's been a topic that you and I have discussed on the live streams earlier. I know it's a topic that you're obviously going deep on this entire year. Tell me something like a workshop perhaps that you attended or just conversations that you had that helped you, sort of feel like, you went to the right place to learn more about RL.
Yeah, actually, there's this good workshop, Foundations of Reasoning in LLMs. That's the workshop in which actually Nathan Lambert also spoke on. In that, there were actually good talks on reinforcement learning in general, especially focused on how would RL training affect LLMs. So there was this good talk by a person from CMU. I forgot his name, but his group was investigating actually how is RL affecting in different scenarios, and then it almost felt like an empirical study, but with a well-guided experimentation. So essentially, they tried to simplify some of the term or some of the setup, and then they tried different variants of RL and see, okay, what leads to learning and what doesn't. So that was really good.
I remember there was a paper earlier this year where it talked about even just with random rewards. It was just obviously more of a empirical study, but there was a paper that just tried to explain just how far we are from optimal RL techniques, because they use like random rewards, I think, and they showed that it was still learning.
Yeah.
So I mean, have we come far enough, or do you feel like we're just kind of on the precipice of something monumental for 2026?
I think there's still a lot of scope. Just random rewards working. We also had discussions on that, especially in the paper. I think Quen improves a lot compared to Llama or other models, which actually doesn't learn much in the randomized reward setting. There were actually similar discussions, as in like even in the open thoughts data set, what people have tried is just a TLD around what open thoughts is. It's a data set of reasoning data where there's a question, reasoning trace, and answer. What they have done is they have actually, for the same question and answer, they have generated 2 reasoning traces and then tried to distill. Even then, actually, model seems to perform better than just scaling the data points, which also says, okay, there's even more, at least in terms of reasoning, there's even more left to explore. I would say the current RL techniques perhaps aren't, while they are sample efficient, that is, they work on small data points, they I feel are not in generally efficient or as efficient as how humans would learn with reinforcement. So there's a lot left, but will it happen in 2026? I am not sure about that.
Got it. Let me ask you this. There was this, I mean, I'm just looking at some of the notes. Aligning reinforcement learning experimentalists and theorists, ARLET. Tell me about that. Was that an actual workshop? Was that a panel discussion? What was that?
It was actually a workshop where people, where you could submit papers, and then, it was a day full of discussion on that. I unfortunately couldn't attend the workshop, so I'm not sure what went on there.
Got it. I'm not sure, Chai, I don't know if you know about that, or was there a workshop that you want to talk about that you did attend?
Well, actually, I was thinking about the reinforcement learning, and there was a lot of talk about how now you can just do more rounds of it, and there's more layers. I'm not really clear on how it's actually done. It was just, instead of doing 2, now there's 1046. And I was like, okay, well, that sounds like a really big difference in terms of numbers.
And who was that speaking? Who conducted that workshop or the talk?
I wish I could remember. It was just a thing that I was like, oh, that's really interesting.
What affiliation? Was it a collegiate?
I will try to find that for you and send it to you.
Okay, by the way, we've referenced, just for the people listening, we've referenced a lot of papers, a lot of workshops, a lot of people. We will start to put some of this stuff somewhere, wherever you're going to find this. If you're watching it on LinkedIn or YouTube or what have you, and of course, also a great opportunity for me to say, listen, if you're not joining us on Discord, please join us on Discord. We'll put a link to that as well, and you guys can meet us there, and you can reach out to myself and Ritesh and even Chai, and we'll get you in touch with her if need be, if you want to hear more about the work that she's doing. Speaking of Chai, Common Pile, what is Common Pile?
Oh, Common Pile is actually an open data set that you can download. Okay. So it's put out by Eleuther, which is another nonprofit. And they very kindly came to our talk as well. And they actually put out a paper and a poster that they announced at NeurIPS, where they were like, look, here's exactly where we got all of the data for this model that we train, that you can use. You could just use it. Sure. You can download it and just train your own foundational model if you want to.
Interesting. Actually, somebody who actually did that, and their names come up a few times today, Nathan Lambert. He actually talked about Orlo 3 Think. Am I getting that right? I think that's the full designation. I actually watched the talk that was recorded. I think it's on Vimeo or somewhere online. So I was able to watch it earlier this week because you shared that reference with me. But Ritesh, did you watch that live? How was it?
Yeah, I actually watched it live. It's Olmo 3 Think. Yeah.
Okay, I made it Orlo. It's Olmo. Sorry, yeah, Olmo. Sorry.
Olmo. Yes.
So tell me, what is Olmo? It's sort of a reinforcement learning based model that was created by Nathan and team. Is that what it is?
Yeah, it's by researchers at Allen AI. So they also have this objective of making open source models here. Source being both in data and also in weights and fine tuning. They have been releasing bunch of open source models. Olmo series is one of them, and Olmo 3 Think is a reasoning model by them. So in the talk, basically they explain some tips and tricks about how or what problems they faced, and how are their training runs. Like in general, when we think about training models, okay, so you have this data set, you bring it in, then there's this algorithm, either via you have a loss function and then an algorithm, you do SGD. So in theory or in paper, it's that, but the problem comes at the scale at which people are doing pre-training or fine-tuning. So common pile, the dataset that Chai described, it's actually an 8 TB dataset. So, and that's a lot. And you're not running it on one H100, but clusters of H100s.
Did you say 80B?
8 TB.
Oh, okay, 8 terabyte. Okay, got it.
Yeah, 8 terabyte dataset. So yeah, when you're doing large scale distributed training, so I mean things differ a lot because your gradient updates are in different GPUs, and how are you gathering them and doing updates. So there was a little bit on that, and even in terms of RL, like how much time did they spend on RL, and how did they try to make it faster and so on. So yeah, it was quite an insightful talk.
I mean, on that topic, this is super interesting because, there's companies out there that are obviously creating GPUs that can handle larger and larger and larger sets of data and parallelize more and more. And the whole point is that this can help us create the next generation of large language models. But if we start to shift the architecture towards, models that are not any larger or certainly smaller language models, at that point, those GPU architectures, those new ones, are not perhaps necessary from the scale perspective. Are you seeing a trend either way? Like, were there people who were saying, oh man, can't wait for the next microarchitecture that allows us to train a better frontier model? Or was it more about, hey, listen, we're doing this all wrong, or we have a long way to go in terms of doing this better, and doing it better is not predicated on a new microarchitecture. Rather, it's just about us figuring out what's working, what's not working, and then optimizing on top of existing hardware.
I think a point that in general needs to be made is what's been the trend is, like, you don't get new smaller models, like you don't get benchmark breaking smaller models. You actually get larger models, and then
quantize,
people try to distill them, quantize, or whatever it is, and then smaller models are developed. So it's because in general, there was a theory lecture on this as well, which suggests that over parameterization, where basically you have a lot of parameters, helps in generalization. That is, it's easier to train larger models or more parameters. So I would assume that the trend's going to be the same. Like, people will keep scaling, and then there will be a first bigger frontier model, and which is potentially distilled, or potentially we use the insights in developing that into training smaller models, because training smaller models is also very hard. Like, for example, if let's say we take Qwen 3 1.7B or 0.6B and try to do SFT or RL, we see that sometimes, or in few data sets, they don't learn as well as you just do it with Qwen 3 8B or 32B. In fact, we learned this firsthand at DevRev. We were just doing SFT, and just scaling the model a little bit helped us. So I would assume that we still need larger models, but as we push boundaries, or we would get smaller models that push Pareto frontier of intelligence and size.
But they're sort of like born out of those like over parameterized huge models.
Yeah,
interesting. I mean, this is not the perfect analogy, but in the 90s and even early 2000s, we had these Linux versions that were really, really great. And then what would happen is that people would actually fork them and create another flavor of Linux, and that would become super popular. But it was all like born out of that original version of Linux. So I'm always trying to find parallels between what we're seeing today with these large language models and what we've seen with large software projects of the past as well. So it's super fascinating. One thing we should mention is that we actually did have a poster session. Is that correct? Shanae, I think, presented something. Like, can you maybe give everybody a glimpse of what that was?
Yeah, sure. So we talked about our paper, which is One Pass to Reason. So actually, I and Pratik Jain from our team were at NeurIPS. Our paper was accepted to 2 workshops, efficient reasoning and multi-turn interaction. So essentially, we take a setup of SFT, or when you're trying to SFT or on reasoning datasets, or reasoning datasets which include multi-turn conversations, like the training loss, or it's not trivial to calculate loss over entire conversation in one go. So what we do is we actually give an algorithm to do that, or it's rather a clever trick, clever engineering trick, or we take inspiration from other techniques out there and try to arrive at this one pass to reason. That's why we call it one pass to reason. Essentially, you calculate loss over entire conversation in one go, which essentially means, let's say if you're training on very lengthy conversations, you would see training benefits, or your training speed will increase.
And what was the prior? I mean, how were people calculating loss for a multi-turn conversation before, or were people simply not using multi-turn conversations as part of the loss?
Right. So instead of doing it in one shot, people will do it one per turn. So if your conversation has n turns, then you would do n. Compute loss over each and every turn, and you just sum it up. What we show is you don't need to do explicit n forward props. You can just do it in single forward prop with some changing the attention mask and then duplicating some tokens.
Very nice. Okay, we can share a link to that as well among the several dozens of links I'm sure we'll be sharing here. Chai, final thoughts from yourself. Thank you for joining, by the way.
Yeah, no, it's been great. So I wanted to say one thing, which I said in the beginning. I'm just speaking as an attending of the conference, and not as an official, a spokesperson for any entity or organization. But I also wanted to say that, I think one of the things that I took away, because I actually used to be a chemist, and when I was in graduate school for chemistry, I was actually doing computational chemistry, and for a while it looked like it was going to be a big thing, and then it kind of went down, and now it's coming back up with AI, and it's very interesting. And I think a lot of the excitement around it is because the Nobel Prize in Chemistry was actually awarded in 2024 for AlphaFold, and people were like, oh my gosh, this is like revolutionary. And I feel like right now there's a lot of excitement in the scientific community of how do we feed all of this biological, clinical, and chemistry data into a model, and then a scientist can just natural language query it and say, I am looking for everything that could possibly be contributing to this type of pancreatic cancer, or just some kind of example like that, and give me all of the possible protein or genomics markers that I should be looking, that you can kind of query that huge amount of data that would be very difficult to go through. So this is kind of where people are in science. So I'd say that's probably something that I'm really excited to hear more about, and see if there's anything that could come of it, and real life therapeutics that could come out, and it's kind of like a slightly different take than the usual, like, yay, we just have another agent for.
I think Chai, you're gonna have to write a paper about bringing some chemistry innovation next year in Europe. So we'll look forward to your poster session on that. Maybe something. Maybe you can reach out to that Nobel Prize winner and come up with something. I mean, actually before we started recording, me and Ritesh were lamenting about how we had a couple of, I thought, interesting ideas inside our company. One around verifiable rewards around things that are hard to verify programmatically, and then another around the concept of skills and how you formalize them. Both were ideas that we felt pretty convicted within the company, but we just never wrote about. And now, we actually see paper submissions around both those ideas, or at least ideas that have been formalized very deeply and accepted in the market. One was Health Bench, and the other is around Claude Skills, which we talked about last week in our live stream, and I'm just looking at it and I'm saying no more. In 2026, when we have an idea and we feel convicted, we're going to talk about it. So we're not going to wait. So that's my New Year's resolution. I'll stop there on my end. Thanks, guys, for joining. Any final thoughts, Ritesh?
Yeah, I think it was actually very fun attending NeurIPS. I mean, at one point it felt very overwhelming because there were a lot of things happening at once. But gradually, I started to realize we can track the momentum or the second order in which things are moving in multiple fields and focus on our fields. And my New Year resolution is also to write more or talk about the things I'm doing more.
Absolutely. Yeah. And look, if you need a friend, if it's too overwhelming at NeurIPS, I'm always looking for a visit to San Diego or wherever the next one's going to be. And Chai, Sydney. Oh man, do not get overwhelmed next year, Ritesh. Like, take a friend is what I would say. And Chai, final words from you to close us out.
I think there's just a lot of conversations that need to be had about whether or not it makes sense to have machines check the machines work, because there were actually quite a few different ideas that I kept on hearing, and it was sort of like, is it turtles all the way down if you suddenly just have an LLM checking the output of the LLMs, and AI scientists that write the papers, and another AI that checks the paper that it produces. I'm like, well, at a certain point, what does that even mean? So I would say, like, I would love to kind of think about that as everybody goes out into the new year.
Well, we started off saying no crazy claims, but then we end with a solid one. So I think that's a perfect way to close out. Chai, thank you for joining us. Ritesh, always a pleasure. To everybody watching this, if it's before the end of the year, we hope you have a great 2026 and a happy new year. And for anybody watching after that, hopefully you're maintaining your resolutions. Thank you, everybody, for joining us. We'll see you next time. Take care.
Bye.
See you later.